In this episode, I'll talk about the recent challenging experience with my Keystone Dometic water heater, the troubleshooting process, and the steps we took to fix the issue. Losing a water heater while camping is no fun and will likely mean you're at the mercy of the local campground showers and have no hot water in the rig for washing dishes. Hey everybody, I'm John Marucci. I'm an avid traveler and teacher and love to explore. In 2016, I decided to travel by RV and have never looked back. I've had my share of problems along the way, and being a teacher by nature, I've tried to turn these problems into help for others. Whether new to RV travel or experienced, you're in the right place. So let's jump in. I'm usually thorough about testing my RV systems before trips, and this latest trip was no exception, except we did not dewinterize before leaving due to colder weather. This meant we did not flush the plumbing lines of RV antifreeze or unbypass the water heater. The problem arose at our first stop overnight on the road. Temps were above freezing, and we decided to dewinterize. We happened to be at a full hookup Love's RV stop, which allowed us to flush the plumbing lines and fill the water heater. After dewinterizing, we turned on the propane to the water heater, and it tried to start, but the propane ignited for a very short time and then stopped. The water heater's 6-gallon tank was full of pressurized water, and the electronic ignition had a clear spark, but after the first try, the propane would not ignite. The unit tried to start the usual 3 times before faulting out. Next, we tried the electrical heating element, which also would not come on. Usually you can hear the electric element relay switch being powered by 12 volts to allow the 115 volt switch to engage. There was no indication from the water temperature that the electric element was working. I thought something common to both items had failed, so I sought a YouTube video to look for the best way to test the unit. I own a multimeter and followed an excellent video on how to test the water heater using a multimeter, which I'll link to in the description. However, while I will show what I did, this video is not a tutorial on how to use a multimeter, nor am I an expert. This video will show the testing I did to diagnose and solve the issue. If after watching this, any of this seems too complicated or dangerous to you, please contact a local RV dealer or mobile tech for help. Before we get into what I did to troubleshoot my unit's issue, let's look at the wiring diagram for the Dometic GC6AA 10E water heater. Atwood has made this 6-gallon gas electric unit for a long time, and Dometic purchased Atwood in September of 2014. On the top left, you'll notice that 12 volt power goes to the 2 switches, gas and electric, and then to the control board via a white wire for electric and an orange wire for gas. When either switch is turned on, 12 volt power should go from the rig's battery through the fuse box to the switch and then to the control board. Next, a brown wire sends 12 volt power from the board to the fixed temperature thermostat or T-stat. This module physically contacts the water tank and is set to break the 12 volt power flow when the tank water reaches 140 degrees. This effectively turns the power off to both the gas and electric processes when the water reaches full temperature. A thermal cutoff fuse on this line is set to melt and break the connection as a backup if, for some reason, the unit overheats. The brown wire completes the circuit back to the control board after the thermal cutoff fuse. Let's focus first on the electric side of the operation. It's vital to understand the purpose of the yellow wire in this process. With the electric side switch turned on, this wire should send 12 volts to the electric heating element relay switch as long as the tank water is below 140 degrees. This current causes the relay to close, thus sending 115 volts from the AC side of the rig's electric box to the water heater's 115 volt electric heating element. If no or low voltage comes through the yellow wire, the relay will remain open, disconnecting the power to the electric heating element. If the electric side switch is turned on and the water temperature in the tank is less than 140 degrees, 12 volts should be present on this yellow wire and 115 volts should be present at the heating element. On the propane side of the operation, the red wire should send 12 volts to the ECO switch when the propane switch is turned on, as long as the T-stat and thermal cutoff fuse are working with the water temperature below 140 degrees. The echo switch is like the T-stat in that it physically touches the water tank and measures the temperature of the tank. It differs from the T-stat in that it is set to break the flow of electricity if the tank reaches 180 degrees. This switch will only interrupt the electric current if the tank gets hot. Suppose the echo operates correctly and the water tank temperature is less than 180 degrees. In this case, the 12 volt current should flow to the propane gas valve and keep the valve open, allowing propane to flow through the valve's small orifice for ignition. If the propane side doesn't ignite, the blue wire will send a fault signal to the remote lockout lamp, indicating that it did not ignite. It does this after 3 separate attempts to ignite. There is quite a bit to understand before getting started with troubleshooting, so feel free to pause or re-watch the details around the wiring diagram before proceeding. These diagrams are in the blog entry for this video on johnmarucci.com. Understanding how the electrical process works is essential before troubleshooting the unit. To troubleshoot, you'll need a multimeter that can measure DC and AC voltage as well as continuity. I got a relatively inexpensive one at a local Harbor Freight. We'll try to be very methodical as we walk through the troubleshooting process. As a reminder, here are the symptoms. We had a clear electric spark at the igniter when turning on the propane switch, but no propane igniting. It would try to ignite the 3 times and then fault. The heating element never came on to heat the water on the electric side. Also, we had working propane at the stove and furnace, eliminating the possibility of propane not being available. We decided to test the propane side first, and the troubleshooting guide in the owner's manual was helpful. There is a section that is labeled Water Heater Lockout, Spark Present but No Gas. There are 12 potential causes presented, 5 having to do with some sort of restriction to the actual propane flow, and 7 having to do with electrical issues. At this point, I decided to investigate the electrical issues for 3 reasons. First, we had propane working correctly in the rig. Second, we had the concurrent issue of the electric heating element not working. And third, I talked to my dealer's tech who said he had rarely seen a gas valve fail. He thought it was not a propane flow issue as long as the gas orifice and tube were not clogged, which I confirmed were not. So let's go over the testing performed using the multimeter to eliminate potential causes on the propane side. The first step is to check that 12 volt power is getting to the control board when the propane switch is turned on. Do this by setting the multimeter to DCV and putting the multimeter's black lead to ground and red lead inserted in the connection of the orange wire at the board. You should read at least 12 volts. Be aware that the owner's manual dictates that a minimum of 10.5 DC volts is required for proper operation. If you're not seeing proper voltage, the propane switch may be bad, the 12 volt fuse in the electric panel may be bad, or your rig's battery may be bad or require charging. In my case, we had 12.24 volts coming to the control board with the propane switch turned on. If this connection has proper voltage, the brown wire coming out of the board should also have proper voltage. To test this, keep the black ground lead from the multimeter touching ground, move the red lead, inserting it into the brown wire connection at the board. You should again read the proper voltage. In my case, it read 11.44 volts at the brown wire. Less than 12 volts, but enough to work. Next, follow the brown wire to its first stop, the T-step module, which cuts the power flow once the tank reaches 140 degrees. To test, again, leave the black lead touching ground. Remove the female connection on the brown wire at the T-stat and insert the red lead of the multimeter. We tested and had 12.29 DC volts. Next, reconnect the brown wire to the T-stat and remove the thermal cutoff fuse from the other side of the switch. Test the voltage passing through the T-stat by touching the red lead of the multimeter to the module's bare post. You should have proper voltage running through the unit as long as the water temperature in the tank is below 140 degrees. We had 12.29 DC volts, so there was no problem at the T-stat switch. The next step is to test the thermal cutoff fuse. Do the same test by having the thermal cutoff fuse connected to the T-stat module with power on. You should see the same voltage reading at the thermal cutoff fuse male connector. If not, the fuse itself may be damaged. We still read 12.29 DC volts, so the fuse was fine. Next is to check the DC voltage returning to the board at the brown wire by inserting the red lead of the multimeter into the wire socket, always keeping the multimeter's black lead to ground. You should again have proper DC voltage. If there isn't proper voltage, you may have a loose connector or bad wire returning to the control board. If you do have proper DC voltage returning to the board, the issue is likely downstream. Here, we tested at 11.52 DC volts, so we still had a passing grade. The next test for the propane side would be to check for 12 volt power at the red wire socket at the control board. This wire sends power to open the propane gas valve. Insert the red lead from the multimeter into the red wire's connection at the wiring harness. There should be at least 10.5 volts at this socket powering the red wire at the control board. As you can see, this test failed, showing erratic readings and coming in below the needed 10.5 DC volts of steady current for some reason. This meant that enough voltage was getting to the control board, but not coming out of the control board to the red wire that feeds power to the echo module and gas valve. This almost certainly meant that the control board had somehow failed. Since the gas valve requires at least 10.5 DC volts to operate, the gas valve would not open given low voltage. When testing the red wire at the echo switch, we had a steady 8.18 DC volts, well below the necessary 10.5 DC volts to open the propane gas valve. We also tested at the exit of the echo switch and had 8.19 DC volts. This showed that the current was passing through the echo switch properly, but was insufficient to open the gas valve. All this pointed to the control board as the issue. This could also explain the concurrent problem with the electric heating element not working. It was easy to test this by turning on the electric switch inside the rig and testing that power was arriving at the control board, but not going out through the yellow wire that controls the electric heating element relay switch. By testing this, we had no current getting to the yellow wire at the board. Given that the red wire for propane valve operation and the yellow wire for the electric relay switch were putting out less than the required DC voltage, we decided to replace the control board, as this seemed to be where the problem was located. In gas and electric operations, sufficient DC voltage was getting to the control board after the T-stat and thermal cutoff fuse, but not exiting to the red and yellow wires that control the gas valve and electric heating element operations respectively. You should research and purchase the correct control board for your water heater model. We used the product sticker on the inside of the water heater cover to identify the model number and associated part required. The well-rated replacement control board we needed was over $100 on Amazon as of the making of this video. I ordered it and it arrived the next day. Replacing the control board was relatively easy. Here are the steps to remove the defective control board. First, ensure all power to the existing control board is turned off at the switches. Next, disconnect the 2 wiring harnesses. Next, disconnect the igniter wire from the board. Next, unscrew the control board's 2 mounting screws and remove the board. To install the new control board, reverse the above process. First, install the board with the 2 mounting screws. Next, attach the igniter wire to the board. Next, attach the 2 wiring harnesses. We did have a bit of an issue when reconnecting the 2 wiring harnesses. After connecting the top harness, the bottom harness was a bit difficult to get seated properly. The solution was to remove both harnesses, seat the bottom harness first, then seat the top harness. The plastic tabs should seat fully to indicate the harnesses are correctly connected. After installing the new control board, we need to test the system. First, turn on the propane switch inside the cabin. Next, go outside and look for the igniter to spark and the propane to ignite. It may take a few times as air is bled from the propane line. If it does ignite, you know that DC current is correctly passing through the red wire and keeping the gas valve open. In my case, the propane ignited almost immediately. Next, turn the electric switch on inside the cabin to test the electrical side. DC current should close the electric relay switch, allowing 115 volts at the electric heating element. You can test for 115 volts at the electric heating element by locating the heating element and testing for AC voltage at the heating element's AC wiring input. Be very careful as this is much higher voltage. First, turn the breaker off to the water heater at your electrical panel. Locate and remove the relay switch cover to access the area. You can test for 115 volt AC current by changing the multimeter to ACV, very carefully grounding the black lead of your multimeter and putting the red lead on the hot side of the heating element. This should be a larger diameter black wire. Turn on the breaker to the water heater and test for proper voltage at the heating element. We did this and had about 117 volts, so everything was working correctly again. Remember to turn the breaker back off and correctly reassemble the relay switch before turning the breaker back on for service. Hopefully this was helpful for you to understand better how to troubleshoot a common water heater problem. Besides showing what I did, my hope is that this video will let you see if this is something you may want to tackle yourself, or if you should contact a local dealer or RV tech for help. Remember, you're dealing with live electricity, so please be very careful if you decide to do this type of work yourself. The video showed what I did to solve my issue and is not an expert opinion or a certified training video. Okay, that'll do it for now. If you found this video helpful, please click the like button, share it with friends on social media, and remember to subscribe to the channel. Thanks for watching. Stay safe. This is John Marucci, and so long for now.